Hey guys, Zoom call here. As always, I'll be answering as many questions as I can that I've received from students. I'm also going to go through as many of the problems as I can. This week, since I haven't had anybody from college algebra showing up, I'm going to focus upon the calc class because I have had people from the calc class showing up and sending me a lot of questions, and I want to give them as much opportunity as I can to answer those. I will still post solutions for the college algebra ones, so that you can check your results and try to figure out what you did wrong. But I will be focusing the majority of my time, at least 30 minutes of it, on just the calc side. So I'm going to keep working on my solutions for the college algebra ones, and you can watch me do that for a little while. But then around the 12:30 mark, I'll switch over to the calc side and start answering some of their questions and giving them some more extra practice. So go ahead and switch over. As you can see, for a lot of these, I am not doing a lot of showing my work. This is mainly because, well, you don't need it. If I don't want to sound that way, but you can actually get away with showing less work if you are willing to learn how to do these techniques faster and easier. Is one of the things I'm doing. These are all the solutions for day 16. I'm going to keep working on day 17 here. And let's go. Hey, Miranda. I will be finishing these problems. I'm not going to do any explanations on them or anything. I'm just going to work on these problems. And then in about 20 minutes, I'm going to switch over and do the calc problems. So if you have any questions then, feel free to ask them, all right? Okay. So let's see, number 4. Let's see how good I am at not showing my work here. Number 5. Number 6. Ooh, okay, these was in my head. Yeah, of course. Seven. Eight. 9. 10. Why are these gotta be so cruel? Doing it on my head's hard. Very good. 2x minus 1 over x plus 5. Mhm. Okay. Okay, those are all so far. Okay, second part. Let's see here. I'm not going to simplify these at all because I can. 14. Okay, so 14. Okay. Beautiful. 15. 16. I hate the letter B. Why do they constantly use it? There we go. Number 20. 923. Yeah, it wasn't so bad. All right. So got at least half the homework shown. I think that's pretty generous here. So day 16, day 17 are done. Day 18, just keep in mind you have to flip the fractions over, and then you can do the same basic steps we did here. For 19 was a new material today. If you can simplify a fraction, you can simplify these, just takes time. I didn't mean to assign quite this many on day 17. I meant to say to only do the odds, but I didn't remember to type that in. And then the next day, I was surprised whenever I saw how many I had assigned. So apologies. I will make it up for you somehow next week. But for now, we're about halfway through. I'm going to start doing some of the calc problems. Calc problems. Calculus is the superior math, by the way, in every way. So, Miranda, did you have any questions you wanted answered?
Yeah, day 17, and I haven't started on today's homework. Day 17, I got really confused on because I don't know.
Okay.
There's A, B, and C, and it's, X to C plus. At first, I didn't understand what the plus and the minus and X to C was, and I think I finally got it because it took me forever.
Sure.
It took me till today. But I'm still confused on what we're supposed to do.
Sure. Let me just go ahead and get this set up. So I got day 16. How many problems were there on day 16?
There is 1 through 6, and 16, day 16.
Yeah, there was just one problem, right? 95 parts A, B, C, and D.
Yeah.
Okay, I'll leave space for those. All right, let's go to 17.
But yeah, and day 17, there's 1 through 6, 7 through 12, 7 through 14. So 1 through 14.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 14. All right. Let's start with number 1. Okay, so the plus symbol means analyze as you're coming from the right-hand side what is happening. Now, for many of these, the right and left-hand side should match.
Yeah, that's what I figured.
For number 1, all 3 of these should have the same answer.
Okay, that's what I had. That's why I got really confused.
A, B, and C should all equal 3.
Yeah, and it's
Y value
because it's a line.
Yep. On 2, it's the same thing.
Oh.
Because all 3 should be approaching the same value, which is -2. Where it gets interesting is questions like 5 and 6. So like 3 should be the same way. A, B, and C should all be the same. Oh, I got to remember to discuss continuity. So number 1 is continuous. Number 2 is continuous. Let's go to number 3. So on number 3, the big thing to note on number 3 is that the limit from left to right and the limit overall should all be 0. But it is not continuous at 3. Because there's that hole there where the dot is shifted up, that indicates that there should not be a value there, which means you have a hole in your graph. I described it in the video as the roller coaster effect. If you were a roller coaster on this graph, you'd fall to your death at the point 3. And so while the limits all equal 0, it's not continuous. And the same thing happens in number 4. All 3 limits exist, and they're all 3 at the same value, which is at positive 3. But it is not continuous at negative. And remember, you define the limit by the y value, you define continuity by the x value.
All right.
On 5 is where we start to see some changes. So for A, on number 5, the value from the left would be, so that's, part A is from the right-hand side because it's a plus sign. So that would be negative 3. B, which is the value from the left-hand side, would be positive 3. Because, okay, so the minus sign means values as we approach it from strictly the left-hand side. The plus sign means as we strictly approach it from the right-hand side. From the right-hand side, we are approaching negative 3. From the left-hand side, we are approaching negative 2, which means for part C, there's no solution because the limit doesn't match. They have to agree upon the center, which means it's there.
Okay. So it's not continuous, and they're approaching 2 different values.
Yeah, so A is negative 3, B should be 3, and C should be doesn't exist, or no solution.
Okay.
Okay, number 6. The A value, which is from the right-hand side, would be 0. Because from the right, we are approaching the value of 0. From the left, which is part B, we're approaching the value of 2. And because they disagree, C should be no solution. And again, it's not continuous at negative 1. Okay, 7. Find the limit if it exists. If it does not exist, explain why. In this case, the limit does exist. Number 7, it is 1 over 16. And you can apply that analytically or numerically.
Yeah, because it's 8 plus 8 is 16.
Yep. Number 8, that should also exist. Should be negative 3 over 10. Same reason. Yeah. Where number 9 gets funky, or number 9 is where we start to get a little funky. Because
it would be 0 over 0.
Yeah. So in this case, you should use either the numerical technique, which will give an answer, or you can do what I did, which is I just simplified x minus 5 over x squared minus 25. This is just x minus 5 over x minus 5 times x plus 5.
Yeah. And then you cross this out.
X minus 5, which leaves 1 over x plus 5. We can then actually apply that limit, and we should get 1 over 10.
1 over 10.
Same thing or something similar should happen on number 10, though it's a little harder because it doesn't simplify as nicely. But again, you could always do the numerical approach instead, right? I want to approach 2 from the right-hand side, so I could do, we figure out what happens at 2. We can figure out what happens at 2.1, 2.01, and 2.001. Or you could simplify it manually, but either way, you should get the same result, and the result should be negative 1/4. See, I believe if you plug in 2.1, you get like 0.24, no, sorry, negative 0.2496 or something like that. And then it's negative 0.299, and it's negative, dang it. This is why a calculator is helpful. You know what? I'm just going to use a calculator.
There we go.
Okay. Hey, calculator, wake up. Thank you. My calculator says, oh man, it's being slow. I have 2 minus x divided by x squared minus 4. My values at 2.1 are let's see, it's negative 0.2439. That was pretty close. Do it again. Do the value at 2.01, which is negative 0.24937. And then do my last one. Should be obvious. We're approaching the set value of negative 1/4. You can usually tell which approach somebody does by whether they give their answer as a decimal or they give it as a fraction. So negative 0.249937. So you can see we keep adding a 9 in the middle here, which makes it really close to negative 1/4. So yeah. Let's see. What about number 11?
It's just gonna be 0, 0. Well, it'd be negative 3/0.
Correct. Which means in that case, the limit is probably going to be undefined. But I can actually use my calculator to check that. I'm going to use the graphical approach. So I plug in that equation, which for mine would be x divided by the square root of x squared minus 9. So I'm going to graph, looking specifically around negative 3. It appears there's an asymptote forming, and so it told me the limit does not exist. Oops, sorry. Can't see that very well, can you? Oh, it's not much better. Oh, stupid phones. Yeah. Let me pull up this one somewhere. Okay, let me pull up my calculator on my computer. Here is Zeus. All right. Graph calculator. I'd have x on top divided by the square root of x squared minus 9. You actually can do this analytically. It's just a pain. You have to rationalize the denominator to make that work. And you can see as we approach negative 3 from the left, we are clearly descending towards madness and negative infinity. The problem with doing it numerically is that if you do it numerically, you have to make sure to pick values that are to the left of negative 3. So on this one, values that are left of negative 3 would be like negative 3.01, negative 3.001, and 3.1. It looks backwards because it's negative. Remember, these are numbers that are more and more negative as opposed to being more and more positive. So it's a big trick to make sure you keep in mind that in order to always go to the left or go to the right, you have to either add 0.1 or subtract 0.1. Adding 0.1 will always move you to the right. Subtracting 0.1 will always move you to the left. And negative 3 minus 0.1 is negative 3.1. So it looks a little backwards, but it works. Okay, 13? No, 12. Let's see. We should get a solution for this one because it actually does rationalize.
Yeah.
Yeah, in fact, number 12 is one you can do with the analytical approach. You just have to rationalize your numerator. So you have the square root of x minus 3 over x minus 9. What you can do is you can multiply this by the specific fraction, square root of x plus 3.
Oh yeah.
What'll happen is on top, you'll end up with x minus 9. On bottom, you'll end up with x minus 9 times square root of x plus 3. The x minus 9 and x minus 9 are going to cancel, leaving 1 over square root of x plus 3. And when you plug in 9 here, you should get 1/6, which is exactly what you get if you do it the other way, like for the numerical approach, or if you do it with the graph. So some functions that don't look like they can be simplified analytically can. You just have to be creative. And that's why your algebra skills have to be super on point to get calculus really well. Like you can get away with not doing this, but it's just a pain. 13 and 14 are really similar. If you graph these, what kind of calculator do you run?
I usually, well, my calculator is TI. Once I find out, I think it's an 84, so it's a really old one. I haven't been able to afford a new one, like one of the nice ones. So I usually just use Desmos to graph my stuff.
If it makes you feel better, when I was in school, TI 84s were the new big thing.
Oh, I've had that thing since like 5th grade, so yeah.
Okay, so does this look like your TI?
I don't even know where I put my TI. Hold on. I just had it. Where did it go? Hello?
So even with TIs are notorious for being good for people who know how to program stuff and terrible for anybody else, because a lot of your buttons are hidden inside submenus. So like, for example, if I want to graph an absolute value, which I can totally do, you just have to know where it is. It's under the math button. So go to the math button and it should be near the bottom. Am I wrong? The math button. Oh, it's in the math tab. So you press the math button and then you go to numbers. And one of the options is ABS, which stands for absolute value. When you hit it, it'll change the absolute value symbol. So you know you got it right. And so you can actually graph this function. And also gets the other one too. You hit the math button right here. And then you go over to num, which stands for numbers, and you want to do absolute value.
Oh, I have a really old one. All right, it's not TI-84. That's the one I was wanting to get. Oh. I have a TI-30. Let's go.
Hey, the TI-30 isn't terrible, but ooh.
Yeah, no, it's really old. I think I've heard of TI-84. That's why I got mixed up, because it's one of the ones like my school has or something.
Probably. A lot of schools buy these because they're a lot cheaper now than they used to be.
Yeah. I can't do most of what you're saying.
Nice.
I don't know. You cannot graph on this one.
What kind of phone do you have?
I just got iPhone 6.
Dang it. iPhones are really nice for a lot of things, but I have a TI-84 on my phone. It's great.
I have an Android too, or some kind of phone, but I have to give that away soon because I just got my new iPhone, and my mom's making me give my old one away to my cousin. So
there is a version of this app that'll get you a good calculator on your phone, like a TI-84. It costs like $5. That's the thing if you're an iPhone user. If you're an Android user, it's free, which is annoying, but it's like $5. And it's worth it if you got the extra $5, but if it don't, then don't worry too much about it. Desmos works fine. Okay. Yeah. And so I'll even switch over to Desmos to make it all this easier. Let's see, Desmos. Where are you at, Desmos? There we go. So let's see. I want to do the absolute value. The absolute value of x divided by x. And so you can see here from your problem specifically says you want to approach this number from the left-hand side, because that's what that negative symbol means. So if I approach this from the left, coming closer and closer and closer to 0, my value is -1. And so my limit would be -1, which seems a little backwards, but it very much works. If I did the same thing with the second equation, which is -10 on top and -10 on bottom, like you can see, I think, is it have it going towards 10? It's 10 from the right, though. And if you come in from the right, well, then it's approaching +1.
Yeah.
And so there's one more.
So it's positive.
And so, yeah, they're just a different way of looking at the problems. Makes it kind of interesting. All right. Did you have any questions about day 18, or you want to look at today's material?
I don't think I had any questions. No, I don't think I had any questions. If I got anything wrong, I just got it wrong, you know? Because I was pretty confident on most of what I put.
Yeah, 18 I thought was easier than 17.
Yeah.
Just because 17 asks it in weird ways.
Well,
Well, then let's open today's stuff, okay? So today's material is like a mixture of day 17 and day 18, okay? The only difference is now you can actually put going to infinity or going to -infinity as an answer. That's the big difference. And so if you can do these in one of three ways. You can do the graphing approach if you want. You can do the analytical approach where you do it via the algebra, or you can do the numerical approach. Any of those three I will accept. Just try to indicate which one you're doing, because otherwise I get confused. Okay?
Okay, so just say which one I'm trying to do
Just
for
put that at like the top of your assignment, where you just say, hey, for all of these, I use this. Or if you're like switching back and forth for some of them, that's totally fine.
Okay.
Make it clear with your work. Like if you're doing the analytical approach, I'll know because I'll see your work. If you're doing the numerical approach, I'll know. But if you do them all by the graph, I won't know if you just wrote down random answers or not.
All right. I'll probably end up using the analytical approach because I'm better at that.
Good,
I think.
good.
I haven't even started on day 19, so I haven't even looked at any of this. But all right. So that'll be.
Okay, so let me show you the three ways you can tell when it's going towards infinity. Okay. Let's start with the numerical approach. So let's look at number 37 for all these. I'm gonna do 37 all three ways, just so you can see it, okay?
All right.
So 37 says we're gonna take the limit as x approaches -1, but we're approaching from the right-hand side. So that tells me if I'm doing the numerical approach, there's my -1. I have to approach it from the right-hand side, so that'd be -0.9, -0.99, and -0.999. And then I plug these three numbers into this function. Now, when I do, I can actually tell what these three answers are going to be. If I look closely, this should be 10, 100, and 1,000.
And that means it's infinity, right?
Yes. And so the fact that this is like 1, 0, 1, 0, 0, 1, 0, 0, 0, that doesn't really matter that much as long as these numbers are increasing at a predictable rate. So like in this case, this tells me we're going towards infinity, which means this limit as we approach -1 from the right-hand side of this function is equal to infinity. Like we don't ever obviously get infinity as an answer here, but like we should be able to see, hey, we're farther away, we're at 10, we get a little closer, we're at 100, we get a little closer, we're at 1,000. We can see we're going to keep going up. That's infinity.
All right.
Like this one could be 10, this could be 100, and this could be 101, and we wouldn't have infinity because we're not going up at a predictable rate. And so you have to be very clear when you look at these three numbers. Is it actually going up every single time by a predictable amount? And I don't mean like plus 5 every time. I mean like this is times 10 times 10. Like it's got to be predictable in some way. Okay? With the graph approach, that's the easiest of them. So
Yeah, just look at it.
Yeah. Just make sure you actually check which direction you're coming from. Otherwise, that can get in trouble really fast.
So you have to make sure you don't look at the left side.
Yeah.
Or the right side if it's for the left side.
Correct. And if you look further along, like the first half is almost all from the left or from the right, whereas the last 4 are all specifically, check both. Check the overall limit as opposed to just the left or just the right. And so sometimes you'll be able to get an answer and sometimes you won't. You just got to be careful. For the analytical approach in 37, since there's nothing to cancel, the analytical approach isn't very good.
Oh, all right.
Right? Because there's no x plus 1 on top to cancel with this x plus 1 on bottom.
Yeah.
And so, but there is a way to kind of logic your way through this. It helps to be a little bit of an abstract thinker. Okay? So keep in mind, I have 1 over a number plus 1, right? As this number is going to get closer to 1 or negative 1, I can predict what's going to happen to this fraction by just kind of thinking my way through it. In other words, instead of writing out this math, I'm going to think my way through this math. So let's pick a number close to negative 1. It's like negative 0.9. Well, negative 0.9 plus 1 would be 0.1. And 1 divided by 0.1 would be a number of 10. And so I can see that my number is, first of all, it's positive. That's a big detail. Because in general, your answers are either going to be negative infinity or positive infinity, or they're going to reduce down to something that's going to give you a nice whole number answer. So if you think it's going towards infinity, you need to ask yourself, is it going to be negative infinity or is it going to be positive infinity? Because coming from the right-hand side, this is going to be a positive answer, guaranteed. Because the numbers I'm plugging are all less than the 1. It's going to be positive. And so I can use that much to tell me, hey, I know if I plug in negative 1, I get a 0 on bottom. The question is, as I approach it, am I getting a negative number on bottom? Or am I getting a positive number on bottom?
A positive.
A positive number will tell me I'm going towards positive infinity. A negative number will tell me I'm going towards negative infinity.
Yeah.
So for the analytical approach, always reduce first. Always reduce first, okay? But if that fails, then ask yourself, hey, how is this trending? Is it trending positive or is it trending negative? Like, look at 38. I know just from looking at 38 what the limit's going to be. But I know that because I can kind of logic my way through it. Take a look at 38 for me. It says the limit as x approaches 1 from the left-hand side of negative 1 over x minus 1 squared. I predict, without doing any math, that the answer is negative infinity.
Because you're approaching from the left-hand side?
Actually, there's 2 reasons. Are you ready?
Yeah.
The first reason is the top number is negative.
Okay.
What do you notice about the bottom number?
It would be, well, it has a negative 1 also.
True. What else does it have?
Exponent.
What is that exponent?
It's squared.
And what happens when you square a number in terms of positive or negative?
Oh, it becomes positive.
So you have a negative number that is always negative divided by a number that is always positive.
Yeah, and that would make it.
Positive is going to force us to be negative. So it's either going to be negative infinity or it's going to be a negative number at the very least, right? This is one of those tricks you can use to figure out how your answer is going to look, how it's going to feel. Okay? Like, I want you to look at 39, and I want you to make a prediction for me and see if you can logic your way through this. it helps to ask the question, is the top going to be positive or negative? Is the bottom going to be positive or negative? Even though we're only approaching a number, we can still ask those questions. And then based upon those two things, I can predict whether it's going to be a negative infinity or whether it's going to be a positive infinity. So look at 39 for me.
It's, if you put the 2 in for the x on top, it would be a positive 2.
So we got on 39, we got a positive on top.
Yeah, and if you did it on the bottom, it would be 0.
But
so
now think as if we're approaching it, okay? So we're approaching 2, but we're approaching it from the right-hand side. So think like 2.1.
2.1. That'd be a 0.1, so it'd be also positive.
And positive divided by positive is going to be positive, which
Yeah.
means my solution is probably
Positive.
there you go. See how you can kind of trick your brain into working itself out? Especially if you know if it's not going to work. Now, again, you should always reduce first if possible. Because if you look at one like 43, like you can try that technique, but really 43 actually reduces.
Yeah, because you can do it.
The analytical approach, yeah.
X plus 3, x minus 2.
Yes. So look for the reducing first, but if that fails, then ask yourself, okay, what's the top acting like? Is the top acting positive or is the top acting negative? What's the bottom acting like? Is the bottom acting positive or is the bottom acting negative? A good hint to remember is that if both the top and the bottom are 0, it reduces.
All right.
Always. Okay, so like on 43, if I plug in -3, I get 0 on top, 0 on bottom, so I know it's supposed to reduce, so I know I've done something wrong. But otherwise, this little technique can get you around a lot of the math. And again, like if you were taking an AP exam, it's not enough to do this. You'd have to actually show your work via the numerical approach probably, or through the graph.
Yeah.
If you're just doing homework, like this is perfect because it's just logic. You're just thinking your way through it. And of course, you can verify your results the other ways.
So, all right. I don't think I have any more questions on it.
Okay, cool.
Well,
I got like a minute left. I'm gonna enjoy this minute. Did the video help you on 61 through 64?
what? Did the video help on 61? Oh, yeah, I did.
Perfect.
Definitely did. Like,
You're
I
not
felt
the
like
only one who
way
asked
better.
about that, so I made sure to get that one.
Yeah. Because I said, I tried to solve like 61, and I even moved on to like 62 after I couldn't do 61, and I couldn't get it, and I got really mad, and I just erased it all because I couldn't get it. And then so I gave up, and I just wrote down what the problem was, and then I just sent it in because I was just so mad. And I was already stressed out that day, so I was not having a good time, so I just gave up on trying the rest of that.
If you're planning on taking calculus next year, or should I say the year after next, because I know you're going to college algebra, if you do, delta x appears a lot. And doing operations with delta x appears a lot. If you're going into any major science, using weird variables is like the easiest skill to master that makes you better than everybody around you. Because like there will be people who in college will fail physics, chemistry, calculus, any of the big science classes because they don't understand variables and don't understand how a number like delta x squared is just delta x squared. Like they're the same thing because delta x is one thing. It's one number. Like
yeah, it's not delta and x, it's delta x.
And I think the problem is that like so many math teachers teach you like there's a number in front of x, so therefore these are two different things.
Yeah, like 3x or something.
And so like in some of my classes, I'll use x delta. That's a little hard to see. But I basically put my delta underneath the x in a subscript as opposed to in front of the x. And that helps people see it just a little differently so that they don't think like this, they think like this. And this is really common in things like chemistry and physics to use subscripts. Like in physics, you'll use something like force sub 1, force sub 2, and the change in force is force of delta. Or in like chemistry, it would be like, your notations for your ions would be like hydrogen +1 or helium sub-0. And so it's just, different way of approaching it. But it's one of those that if you master soon, you'll be far and ahead, better than a lot of the people that you're with. All right, well, it's 1 o'clock. I didn't finish all the homework. I'm going to try to post solutions. I always try to, but no guarantees. Hey, just shoot me a message if you need anything else, okay?
Will do. Thank you.
And that goes for anybody else. All right. Have a good
Bye.
rest of the day and a good weekend.
You too.